Okay, so let's take a look at some Euclidean algorithms, Euclidean division algorithm and the Euclidean GCD algorithm. So first we're going to look at the GCD division algorithm, and we'll see how you could use that to compute 28 divided by 3. So the way that you would work this is you would say you start with that value 28, and we're just going to keep subtracting 3 from that number. So the first time we're going to subtract, and that's going to bring us to 25. Next time we're going to subtract that minus 3, it's going to bring us to 22. And then we're going to subtract another minus 3, and it's going to bring us to 19, then to 16, then to 13, then continuously down to 10, 7, 4, and 1. Okay, we're just going to keep subtracting. And what we'll see is that if we take a look at what we've done, here we've made this subtraction 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So that's 9. Okay. And at the end, we just kept going until we had 1 left over. And the idea behind this is now we can say, well, that 28 is equal to 9 times that 3 that we subtracted plus 5. And our goal with this is just to keep subtracting until we get down to a value here that is, when we're dividing by 3, we want it to be between 0 and up to but not including 3. So 0, 1, or 2. So we want that remainder to be in a reasonable range. We want it to be in the range 0 to 2. Okay, so we can do the same thing with 53 and 4. Essentially, every time we're going to subtract 4, and so it's going to go from 53 down to 49, down to 45, onward down to 41. 4 less than 41 would be 37, then 33, 29, 25, 21. Where would this go? 21 down to 17. I'll just turn the corner. I will keep subtracting. We'll keep subtracting 4, so that's down to 13, and down to 9, down to 5, and finally down to 1. And so what we see, if I count this up again, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and we ended on the 1, okay? And so what that gives us is that 53 is equal to 13 times 4 plus 1. Okay, so we can do the same thing over and over and over again, and we'll see 61. If we subtract 5, we can do this multiple times, and so this would be 56, 51, 46, 41, 36, 31, 26, 21, 16, 11, 6, 1. So I keep ending. Ironically, we keep ending with 1 left over. But if we were to count up the many arrows in this, we would see that we would actually have gone through that 12 times. And in the end, we're going to have 1 left over. And so, in fact, 61 is equal to 12 times 5 plus 1. Okay. 74 and 11, same idea. 74, we're going to keep subtracting 11. And so we'd first get to 63, and then we go to 52, we go to 41, and so on. So 30, 11 off of that brings us down to 19, and we can carry on. Minus 11, it leaves us with 8. Okay, so this time we can see that this, whoops, come back. That was 1, 2, 3, 4, 5, 6. So that's 6 times we subtracted 11. So 74 is equal to 6 times 11 plus, and this is where we get that last bit remaining, plus 8. Okay, and so that is how one way we can approach that. So we can also use the GCD Euclidean algorithm to compute the following. Okay, so if we want the GCD of 273 and 303, which is really, we can say that's, the same as, so we're going to always use the larger number first, the GCD of 303 and 273. Then what we want to do is we're going to start with the bigger one, 303, and say that's equal to a certain number of 273s. It's 1 times 273 plus something left over. And so what's left over in this case is 30. Okay, and now what we're going to do is we're going to take these values and we're going to scoot them over. So what you'll see is I'm going to then say 273 is equal to a certain number of 30s, right? And so how many 30s can I fit in there? I can fit 9 times 30 is 270. I'll have 3 left over. Okay, and so at this point, I see that I'm going to move the next ones over. So 30 and 3, and they're going to go over. I'm going to say, okay, well, I've got 30 is equal to 10 times 3 plus 0. And as we know, once we get down to that 0, we stop. And then we look up and we say, oh, this is our answer. Oops, leave my little arrow. And then I can say, okay, well, the GCD of 273 and 303 is actually that 3. Okay, so the other way that one can certainly write that is just to say that GCD of 303 and 273 is equal to the GCD of 273 and 303 mod 273, which is that remainder, that 30, which is equal to the GCD of 30 and the remainder when I divide 273 by 30, which was that 3, which is where it's all coming from, which is equal to the GCD of, which is equal to the GCD of 3 and 0, which is 3. Okay, so either way, whatever makes you happy. I'm going to use the left-hand side, but this is where that's another way that one could write that. Okay, so if I deal with this, I'm going to start here, 660. So I'm going to work with these values. 660 is equal to 2 times 312, which is 624. And then I'm going to have a certain amount left over, 624 plus 36. And then I'm going to go ahead and say, okay, well, and 312 is equal to how many 36s? This case, you can do some quick calculation. I can't fit 10, I can't fit 9, I can fit 8 times 36. And I'm going to have 24 left over this time. So remember, these values are moving over like this. Okay. And now we're going to go ahead and say 36 is equal to a certain number of 24s, right? And so this is, now I'm moving them over again. This is where these values are coming from. I can only fit 124, and I'm going to have 12 left over, right? And now 24 is equal to a certain number of 12s. And so we're, again, oops. Trying to move it over. Not sure if I lost my pencil. Hold on for 1 second. Okay, so we'll move those over again. And so this is 2 times 12 plus 0. So that's where we stop, and that's when we know that this is our winner. And so this is the something I'm doing is making it go away. Or maybe it's almost dead. The GCD of 660 and 312, as we started, oh yeah, I have no pencil left, is going to be set to 12. So I think I'll stop with that one. And it certainly leaves one last problem to do, but it sets you off on the right point. So the answer in this regard, apparently I have no pencil anymore to make use of, but hopefully maybe it will come in for just 1 second. 660 and 312, which you can flip those two, is 12. Okay, and that ends that. So on to the next one.